Adjoint of a matrix. So what is adjoint? So first thing it says adjoint of a square matrix. Again you see it's a square matrix. The square matrix is the most important one. Everywhere you will see square matrix. So adjoint of a square matrix Aij, n cross n means what? The order of the matrix is n, is defined to be transpose of Aij n cross n. Acha, can you guys tell me what is this capital Aij? Who can tell me what is this capital Aij? Capital Aij means what?
Row and column.
Row and column. Capital Aij, where we have seen capital Aij, it means cofactors of small aij. Understood? Adjoint of a square matrix A is equal to small aij, that is the elements of order n, is defined to be transpose of capital Aij, where Aij is the cofactor of the elements small aij. Understood? Clear? So first I will do what? I will get a matrix of cofactors. So suppose, so adjoint of A is written like this. It is Adj A. So if I have to find adjoint of any matrix A, so I will write Adj B. Suppose I have to find adjoint of B. Am I clear? Understood? So that's how we denote adjoint. So now you see, suppose I have a matrix A, where A is given by A11, A12, A13 like this, right? Then adjoint of A is equal to what? What they have defined about adjoint? Adjoint of A is transpose of a matrix which is formed by the cofactors of these elements. Can anybody tell me what is capital A11? What is capital A11? Capital. Yes, that's right. So these are actually what? These are the cofactors of these elements. So first you have to find the cofactors of these elements, then you have to transpose this matrix, then you get the adjoint of that matrix. Understood? So suppose they have given you one matrix. The first step what you will do? First you find the cofactors of each of the elements, right? Then you form a cofactor matrix. Then you transpose that matrix and then you get an adjoint of that matrix. Understood? Clear? Even if you're not clear, then when we do problems, then you will be clear. Okay? Now let us see how to find adjoint of this matrix. This is what we are discussing about 3 cross 3 matrix, right? Now if I have given you an example for 2 cross 2 because the spaces is less, that's why. So if I have a matrix A which is 1, 2, 3, 4, I have to find the adjoint of it. So what is our first step? My first step will be to find the cofactors, right? Now everyone tell me A11. What is the cofactor of A11? It is 1, 1. So minus 1 to the power 1 plus 1. It's even number. Please clear this up. We don't want to write minus again and again, right? So it is positive. And the cofactor of A11 will be what? Cut this one and this one. It is 4. Understood? Everyone, you have a very good idea of cofactors, right? Understood? Now A12. 1 plus 2 is what? Odd number. So it's a minus sign will come. Minus 1 to the power 1 plus 2. So it will be a negative. So minus, and what is the cofactor of? What is the cofactor of 2? So it will be cut this one and this one. That is 3. So it will be minus 3. Now you tell me what is the cofactor of A21. A21, 2 plus 1 is odd number. Odd number, so it will be minus. And since it's minus, then what I will do, A21 is this element, 3 is A21. So cut this one and this one. So what element remains? That is 2. So it is minus 2. Now the last one, I made a mistake. I have to write this one A22, yes or no? Yes. So A22, what is the cofactor of A22? Cofactor of A22, it will be cut this one and this one. So what I get? I get 1. So A22 is 1. Understood? Clear about the cofactors? Okay. Then adjoint of A is what? Adjoint of A is equal to transpose of the cofactor matrix. Look at here. A11 is 4, A12 is minus 3, A21 is minus 2, A22 is 1. Now transpose of this thing means what? The row becomes column, the column becomes row, right? So 4 minus 3 is the row, 4 minus 3 becomes the column, minus 2 1 is the row, minus 2 1 becomes the column. Understood, everyone? Did you guys understood how to find adjoint of a 2 cross 2 matrix? Am I clear?
Yes, sir.
Yes. Now let's move on to... Yes? Clear? Now tell me. Now there is a shortcut method to find the adjoint of a matrix of an order 2. So what is the now this shortcut method is only applicable for order 2. Listen very carefully. Only for order 2. Understood? It's not for order 3 or any other order. It's only for order 2. So if I have a matrix A11, A12, A21, A22, then adjoint is, we can directly write, just shift the position of this one. A11, A22. Write A22 here, A11 in here, and change the sign of these two. Minus A12, minus A21. This gives your adjoint. Am I clear? This is a shortcut. So I will shift the position of this two. I will shift the position of these two and I will change the sign of these two. Am I clear? Now look at here. I will write directly 1, 2, 3, 4. What will be the adjoint? The adjoint will be, I will shift the position of this two. 4, 1. I will change the sign of these two. Minus 2, minus 3. You see it's correct. Am I clear? Understood? Yes or no? Yes, sir.
Yes, sir.
Okay?
Yes, sir.
Yes, so let's move. And if you have any doubt, I will post this video in the YouTube channel and you can go through that again. Okay? Now, we have some theorems. Adjoint and inverse of a matrix. It's the most important part of this chapter. Theorem 1. If A be any square matrix of order n, then A into adjoint of A is equal to adjoint of A into A. Acha, have we seen this one before? Can anybody tell me, have we seen like this before? Acha, fine. If you don't realize, I will tell you. Doesn't this look like this one? AB into BA. Yes or no? A into adjoint of A is equal to adjoint of A into A, right? AB is equal to BA, right? And this law was what? This law was known as commutative law, right? You guys forgot, that's for sure. And that is equal to, this one we will prove. A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. Acha, what is I? I is what? Actually, I have removed. What is I? I is an identity matrix. And what is the order of I? It's n. Acha, can anybody tell me why have I taken I of order n? Why not 2? Why not 3? Why not 5? Who can tell me? Why have I taken I as order n? Huh? Why the I is of order n? Because the A matrix which we are dealing with, the original matrix, the order of that thing is also n. If the real matrix, the square matrix is of order 3, then I will be of order 3. Understood? Am I clear? Now, next step. A square matrix A is said to be singular if determinant of A is equal to 0. If I find a determinant of a square matrix to be 0, then the determinant, then it will be known as singular matrix. Okay? If the determinant is not equal to 0, then it will be known as non-singular matrix. It's simple as that. Understood? So if the determinant is 0, singular. If the determinant is not equal to 0, then non-singular. Okay? Clear? Now let's move on to theorem number 2. If A and B are non-singular matrices of the same order. Now non-singular matrices means what? The determinant of A is not equal to 0 and the determinant of B is not equal to 0. Then AB and BA are also non-singular matrices of the same order. Understood? Am I clear? Okay, so theorem number 2 is nothing to understand. If the determinant of A is not equal to 0 and B is not equal to 0, then AB, that means what, the product of the product of the two matrices A and B is also non-singular, means their determinant is also not equal to 0. Understood? Clear? Yes or no?
Yes, sir.
Yes. Now the third theorem. The third theorem goes like this. If I have, this is what? Can anybody tell me what is this thing? AB is what? AB is what? Is a matrix or is a determinant? AB is a matrix or is it a determinant? AB is a matrix, right? Now if I have to find determinant of this matrix, I will just put like this. Understood? Now, if that for determinants, what we can do is, the determinant of the product matrix is equal to the product of their determinants. Am I clear? Understood? Determinant of the product matrix is equal to the product of their determinants. This one also a theorem. Please remember, it's very, very important. You have to know this thing. Okay? We will see this one. This one and this one. We will be proving these two in our exercise. Okay? Now we move on to the next theorem. If A is a square matrix of order n, then adjoint of A, determinant of adjoint of A is equal to determinant of that A matrix to the power n minus 1. Now this formula we will derive. Okay? We'll derive this formula. Let's see. So it will start with adjoint of, do one thing. For the moment, just look at the formula. We'll derive next because I'm recording this video, right? That's why. Now look at here. Theorem number 4. A square matrix A is invertible if and only if A is non-singular matrix and A inverse is equal to 1 by determinant of A into adjoint of A. So these are the formulas which I will derive right now. So this is our adjoint and inverse of a matrix. So that's it.